Nicko Goncharoff is head of knowledge discovery at Digital Science. I actually first met Nicko in his role as head of SureChem before that became part of Macmillan Digital Science. And so this afternoon, Nicko is going to be talking to us about, in fact, SureChem and talking about how text mining can be done in the real world. And then later on, I'll introduce Heather.
Who are you? I'm over here at the podium, yes? Yes. All right. Good afternoon. Howard, thanks for the introduction, and thank you also for putting me after Heather and the Google Glass talk, because I'm going to talk about patents in chemistry. And that, yeah, Google Glass, you don't really want to compete with that. Actually, this is going to be, some of you who know me know I've been involved with this project called SureChem for a long time, and you may be here at my last ever SureChem talk. And I'll go into the reasons why for that. Am I using this? Sorry to be so witless. I was asked to come and talk about text mining and real-world applications, things that Macmillan have done with text mining. And fortunately, something happened recently. I'm able to base my talk around a fairly recent development, which is putting SureChem into the public domain. There's a little, it's wrapped there like it was with context earlier today. But anyway, that's an agreement that we're signing this week. So I'm going to talk about a story with two themes. So it's text mining in the real world, but it's also how proprietary and public content owners can mutually beneficially support open science. So I said the protagonist as if this was an exciting story. It's exciting if you've been working in it, but it may not thrill everybody in the audience. I understand that. But anyway, just humor me. So SureChem, for those of you who don't know, surely there can be almost no one there, right? Is a database of chemistry that's extracted from the full text and images of patents. This is important if you're trying to develop a new drug or any type of organic compound and you want to find out if, in doing so, you're going to get yourself sued by GSK or Pfizer, who usually have more lawyers than you do. It's a database of 15 million unique chemical compounds covering US, European, and world patents from 1976. It's a fully automated system. The data is generated within 24 hours of the patents being published, and we let people find it via a website, or there's an API as well, harking back to earlier discussions today about APIs. I co-founded SureChem in 2007, and we had a development team in New Zealand and in the US. There were a few of us at Macmillan. SureChem was the first acquisition by Macmillan for the digital science business unit, which I'll talk about in a moment, in December of 2009. Digital science, for those of you who haven't heard of that, is a relatively new business unit of Macmillan. We're celebrating our 3rd anniversary on the 10th. And we develop software tools for researchers, basically, software tools and solutions for researchers. So we're a sister business to Nature, but we are focused on the software side of things, although we are generating some proprietary data. But the approach, we invest in external businesses, and most of these are businesses that we've invested in. We also develop some products internally. A few of these are internal developments. The idea was to, Macmillan is building for the future, and they wanted to have a technical center of excellence, not only for themselves, but also to hedge their bets and diversify into other markets. But also Nature has a very dedicated and large user base, and it's a source of excellent feedback for both product ideas and then testing said products and actually getting people to adopt and then buy them as well. So the goals for digital science are to build a portfolio of aligned and profitable businesses, the center of excellence, but also digital science is fairly idealistic, and we have a lot of people whose main goal is to work at a group that provides measurable benefits for the scientific community. And if that sounds a bit idealistic, sometimes it feels like that too. We have 3 business areas. I won't go into that I won't bother with that, but basically what we try to do is we have tools to cover as much of the research cycle as possible, from doing your initial literature research to planning your experiments, and conducting the experiments and then sharing the results with the rest of the world. Okay, the other protagonist in this story is Emble EBI. How many people here know of EBI? All right. Well, so EBI is a life sciences database. It's considered one of the key online public life science resources in the world, along with some of the NCBI databases and things like Protein Database, GenBank, et cetera. Their goal was to assemble the most comprehensive set of databases for molecular biology. So covering everything from sequences to chemistry, gene expression data. And they were founded in 1992. They're part of the European Molecular Biology Lab, and they are considered one of the key public data resources of record. So the reason I'm talking about SureChem and EBI together is the result of some structure and strategy changes at Macmillan. Some of you will be aware that Macmillan has undergone some shifts of late. We restructured our businesses to basically more along functional lines. Macmillan is an old business, and we had lots of different companies that were regionally focused or focused on particular products or customers or basically a combination of the two, and they weren't very aligned. And so now Macmillan has reorganized into two major sections, Macmillan Science and Education and Macmillan Publishers. And Science and Education is in Science and Scholarly, which basically includes NPG and Palgrave, Macmillan Education, which is all the education businesses, and the digital businesses, of which Digital Science and our sister business, Digital Education, are a part. So in doing this, Macmillan made a conscious decision to focus on academic research and organizations, and this has a bearing on SureChem. At the same time, while between Digital Science founding in 2010 and this year, our strategy has evolved. When SureChem was the first acquisition, and since then we made different investments and acquisitions, and our strategy evolved accordingly. Our focus is now in line with Macmillan on academic institutions, researchers, and publishers, and we have shifted towards products that span a wide range of disciplines. What I'm going to talk about today is chemistry for drug discovery, so it's life sciences and a niche within life sciences, whereas many of our products like FigShare for data, altmetric, ReadCube can be applied to any research discipline, even pseudosciences like theoretical physics. That's an inside joke. So and the idea is also to develop a system of mutually supporting products, so that going back to the research cycle. So this meant a shift away from niche and corporate focused products, which SureChem was. So as a result, there should be, yes. So just a little bit more about SureChem to give an idea of what it does and why is it a real world text mining application. What SureChem allows you to do is to draw a chemical structure or enter keywords or search a combination of keywords and chemical structure to get back patents that contain that chemical data or the keywords, combinations of both. It is entirely run by text mining. There's no manual process in here. There was manual process in building the pipeline system, but what we do is we take in XML data, extract the chemistry, and then publish it to the web or via an API. And what then that allows you to do is you can draw a chemical, as you saw before, you get back results, and then you get back patents that contain those results, and then you can jump into the document and you may find a keyword, you may find an image, and then you can navigate directly to where that chemical is located in the patent document. And patent documents usually can run anywhere from 20 to 300 pages in length, so being able to jump directly to it is quite useful. So the reason this is a good text mining application is text mining is designed to handle big data problems, and while 20 million patents and 50 million chemicals pales compared to the data resources of Amazon, Google, Facebook, it is actually still a fairly large problem to solve, and it would be very hard to do all this manually. Our competitors or now I would say colleagues, peers who do this type of thing have historically used manual resources, and it's taken decades and decades to assemble similar sized data sets. So the way that it works, just to show that this is a real world application, we have XML documents and image files. We have separate ways of processing all of those. First, applying software that recognizes words and text or chemistry and images. And we clean up those. We do some standardization. There's actually there's a whole separate set of technologies for correcting errors introduced by optical character recognition processing, which is the bane of publishers and data curators the world around. We have a facility for some type of manual curation, and then, but most of the documents would go through to just be corrected, and assuming we could find a chemical structure to assign to the chemical name that we found, we would publish this as annotated XML documents and then make it available via an API or via a website. So this pipeline we put together, we initially built it back in 2008. We ended up re-engineering it at Macmillan, and it now can handle a fairly massive amount of throughput and basically runs on its own. Since we launched it, we have not had to, we haven't had any downtime in like a year and a half. So this is, again, an example of a real-world text mining application. It's not annotating a bunch of proteins in Medline and then writing a paper. I mean, this is running every day, and people are searching it every day. So, finding a new home. This is getting to the other part of my talk. So we knew that if, for those of you who are familiar with this area of life science data, increasingly people are asking for all the types of data in one package, and you have to be able to compete. You have to be able to offer not just chemistry, but biology, not just patents, but journals, clinical trials. And there was no, this was at odds with the digital science strategy. We didn't want to get into niche corporate products. At the same time, there was we'd done really good work with SureChem, and we valued the underlying technology. We also have uses for the data. So while we didn't necessarily want to continue owning it, we didn't want to let go entirely. So we decided to sell or transfer the business, but with this criteria that we would own the core IP, guarantee our current customers are supported, of course, so Macmillan's name wasn't mud in the pharmaceutical community, and then ensure that SureChem remains a valuable resource for the scientific community. We had a free portal called SureChem Open. I'm happy to report that will continue to be free, and then some. We also needed to close a deal by the end of 2013 because people who were working on SureChem had other opportunities that they could pursue at Digital Science, and we wanted to be able to move them, including me, onto that as soon as possible. So we entertained some commercial offers. We talked to some other public data providers and data resources. We eventually reached a deal with the European Bioinformatics Institute, and we found that they were the perfect match. Basically, they're positioned to make the most of our data and distribute it to the largest group of people who really need access to it. They have the Chemical Small Molecule database is one of the premier databases used by drug discovery researchers and other molecular biologists around the world. They have journals, they have some clinical trial records. They didn't have patents, so it was very complementary to put our data into Chembl. EBI, because they're a public resource, they're not interested in generating revenue, so they were willing to let us retain the intellectual property, the software that annotates chemistry and patents, which is also used by Nature Publishing Group, so that was important for us. They pledged to support our customers. They'll be making the data publicly available, not only, obviously, ensuring access for Macmillan along with the rest of the scientific community. And they are well-funded, so SureChem is in good hands for a long time. It's for those of you who are, again, not familiar, patent chemistry has been locked away. It's been mainly proprietary. The only way to get to it is through subscription, and there are a lot of people who could make use of that who just frankly couldn't afford the subscriptions that were being charged. So putting this in, and it's by no means comprehensive. There is no single comprehensive patent chemistry database or biology or chemistry database for that matter, but with putting this into the public domain, we are opening up a new set a fundamentally new set of data to open science. So again, while we had commercial offers, none could deliver these benefits to us of retaining the IP and getting perpetual access to the data. So we signed a formal transfer agreement this week, and that's why I was able to actually talk about a real-world text mining application and what we were doing with it, because I haven't been able to say anything about SureChem since July, which, since it was a company I co-founded, was a very odd position to be in, but we've been working through the deal. But we will be formally announcing it next week, and it's not as exciting as Google Glass or astronomy, I grant you that, but this is the first time that we are making it officially public. The data probably will not be available on the Kemble site until sometime in the end of Q1 2014. I think it's going to be called SureChem, and I think the logo will be as bad as that name sounds, but there you have it. So the data will be integrated into Kemble, but exactly how users will access it and how, for instance, the API might be available to our pharmaceutical customers when they renew or to other publishers, et cetera, that remains to be decided. And patent chemistry, as I was saying before, joins the ranks of freely available scientific data, and yes, these are the kind of people who would find that interesting. If anybody here is interested in finding out more about getting access to that data, digital science is a little bit different from Macmillan in that we work with other publishers, Figshare, Readcube, Altmetric being examples, and we're not necessarily averse to the idea of others taking advantage of this data set. We do have some rights over who uses the data when it comes to competitors, but if you're interested, you can contact me, and you can also contact John Overington at EBI, and along with acknowledging Macmillan in general for supporting SureChem and then actually taking the decision to support it, transferring it into the public domain rather than a short-term revenue gain, I'd like to thank my colleagues, none of whom are here to appreciate the fact that I'm doing so. All right, thank you very much. Oh.
Any questions for Nicko?
Stunned silence, yes.
No.
I was just interested to know which structures you actually extract from the patents. Is it just examples, or do you do the generic and Markbush as well?
It's mainly exemplified. It's mainly exemplified compounds. It will include prophetic compounds as well, but we do not do any type of automated resolution of Markbush structures simply because it's not really feasible yet. So.
Hi. In the past, SureChem was held up to me and others, I think, as an example of an organisation or of a business model that could make data open on the one hand, but fund that through sort of like the more kind of commercial and enterprise services. Is the decision to sort of surrounding this, is there anything that you can comment in the light of that on the success or otherwise of that model, or has that purely been because of re-strategizing within Macmillan?
After we spent about a year and a half re-architecting that whole system I showed you, and within 5 months of launching the new products, we'd brought in $200,000 or $300,000 in revenue. So the appetite is there. I will say longer term, I think we would have had to decide that we were really going into the corporate market and building complementary products to offer alongside it. I think having just patents and chemistry alone without biology data, without the other data, I don't know how well that would have succeeded, but the model of using API and sales to big customers to support the free website, the costs, I mean, we were in line with our projections, so I think that had we continued down that path, it would have worked out. So it's mainly the strategic considerations. I mean, if someone else is considering that same type of model, I'd be happy to talk to them about it. I think it is sustainable.
Any other questions? All right. So, thank you very much. Thanks, Nicko.
Thank you.